Welcome back to Mystery and Quest, the world of science, where we explore the unknown, unravel the mysteries of the universe, and push the boundaries of human knowledge. Today, we dive into one of the most incredible feats of human engineering, Voyager 1, the farthest human-made object from Earth. Launched over 4 decades ago, this iconic spacecraft has journeyed billions of kilometers, traveling beyond our solar system and into the vast expanse of interstellar space. But what makes Voyager 1's mission so extraordinary? How has it managed to survive the harsh conditions of space? And what secrets has it uncovered in the void beyond our solar bubble? Join us as we uncover the epic story of Voyager 1, a true pioneer that continues to send us messages from the stars. Over the past decades, humanity has collectively explored the vastness of space, sending numerous probes, spacecraft, and satellites beyond our planet. These missions represent our unending curiosity and drive to understand the universe around us. From the early days of the space race to today's sophisticated robotic explorers, most of these objects either stayed in orbit, crashed back to Earth, or burned up in the atmosphere. Sometimes they didn't. Some of these machines met their fate on distant worlds, like Mars rovers ending their missions amidst the red sands or the lunar modules resting silently on the moon. However, sending something far into the depths of space requires significantly more effort. A rocket-fueled effort, calculated with pinpoint precision and executed flawlessly to escape the gravitational grip of Earth. The spacecraft launched to explore the outer regions of our solar system needed a powerful boost to break free from Earth's gravity. They also relied on gravitational assists or slingshot maneuvers from planets they passed along the way, which provided extra speed and energy at no additional fuel cost. This clever technique has been a cornerstone of space navigation, allowing these spacecraft to journey much farther than their initial propulsion would have allowed. With no significant friction in space and plenty of open space, these launched objects continue to travel indefinitely, moving further away with every second, pushing the boundaries of human achievement. The farthest human-made object from Earth, holding the title of our most distant emissary into the cosmos, is the Voyager 1 spacecraft, followed closely by Voyager 2. Both spacecraft were launched in 1977, just a few weeks apart, with Voyager 1 getting its name because it reached Jupiter first, thanks to its faster trajectory, making it the first to capture close-up images of the gas giant. Today, Voyager 1 is now at least 24 billion kilometers, about 15 billion miles, away from Earth, while Voyager 2 trails at around 19 billion kilometers, 12 billion miles. To put this staggering distance into perspective, if you could travel at the speed of light, it would still take more than a day to reach Voyager 1 from Earth. As of this year, these spacecraft are celebrating their 47th year in operation, making them NASA's longest-running space missions, defying the expectations of their original mission timelines. Both Voyager probes were initially designed for a mission lasting only 5 years, primarily to explore Jupiter and Saturn. However, they far outlived their initial purpose, evolving into ambassadors of human ingenuity, venturing into the unknown as they continue to send data back home. Both Voyager probes flew by Jupiter and Saturn, revealing unprecedented details about these gas giants, including the discovery of volcanic activity on Jupiter's moon Io, the complex structure of Saturn's rings, and the intense atmospheres of these distant worlds. Voyager 2 also had the distinction of passing by Uranus and Neptune, making it the only spacecraft to have visited these ice giants. It provided humanity with the first close-up images of these remote planets, revealing their peculiar blue hues, the mysterious dark spots of Neptune, and the sideways rotation of Uranus. These encounters were milestones in planetary science, providing insights that still fuel research today. According to NASA, they are the only spacecraft to directly sample interstellar space, the region outside the heliosphere, a protective bubble formed by the sun's solar wind that acts as a barrier against cosmic radiation and interstellar particles. The heliosphere acts as a shield where the force of the sun's wind balances against the interstellar wind, creating a vast, teardrop-shaped cocoon around our solar system. After crossing this boundary, Known as the heliopause, both Voyager 1 and Voyager 2 entered interstellar space, venturing into an uncharted region that no spacecraft had ever reached. This transition was not merely a crossing of a boundary, but a leap into a vastly different environment, filled with high-energy cosmic rays and particles from exploding stars. However, technically, they are still within the solar system and will remain so for a long time. To truly exit the solar system, they would need to pass beyond the Oort cloud, a distant region filled with icy bodies and long-period comets that stretches nearly a light year from the Sun. Voyager 1 is expected to reach the outer edge of the Oort cloud in about 300 years, but it will take nearly 30,000 years to completely traverse this cosmic frontier. Despite the vast distance, engineers continue to send commands to Voyager 1 and receive valuable data from it. NASA notes that due to the enormous distance, it takes over 22.5 hours for light to travel from Earth to Voyager 1, and the same amount of time for signals to return. This means that when engineers send a command, they must wait nearly 2 days to see if it worked, making every interaction with the spacecraft a slow and deliberate process. This immense time delay showcases the challenges of deep space communication and the remarkable precision required to maintain contact with a spacecraft operating on the edge of interstellar space. In November 2023, a computer issue caused the spacecraft's instruments to malfunction, but by May 2024, Voyager 1 resumed sending scientific data from 2 of its 4 instruments. By June of the same year, all 4 instruments were fully operational, thanks to NASA's troubleshooting efforts. These instruments are currently studying plasma waves, magnetic fields, and particles, providing a window into the conditions of interstellar space. These measurements have revealed how the Sun's influence diminishes and how the spacecraft interact with the broader galaxy, offering a rare glimpse into the nature of our cosmic neighborhood. This data helps scientists understand the nature of space beyond the solar bubble and provides clues about the environment that future interstellar missions might encounter. Voyager 1 also captured one of the most iconic photographs in the history of space exploration, the pale blue, taken in 1990. When Voyager 1 was still relatively close to Earth at about 6 billion kilometers, 3.7 billion miles away, the image shows Earth as a tiny speck of light, suspended in a sunbeam. This haunting image, which Carl Sagan famously described as a mote of dust suspended in a sunbeam, symbolizes the fragility and insignificance of our world within the vastness of space. The photograph was part of a series of 60 images known as the Solar System Family Portrait, which captured the planets from the vantage point beyond Neptune. These images were the final photographs taken by Voyager 1 before its cameras were permanently shut down to save power, marking the end of an era in planetary photography. The mission team had instructed the spacecraft to turn its cameras toward Earth for one last look. According to NASA, Voyager 1 is one of only 3 spacecraft ever to capture such an image, alongside Voyager 2 and New Horizons. The other 2 spacecraft, while capturing distant views of the solar system, never matched the profound impact of Voyager 1's pale blue, a photograph that has since become a symbol of our shared existence on a tiny planet adrift in the vast cosmic ocean. The photos that made up the symbolic image were captured just an hour and a half before Voyager 1's cameras were permanently shut off in February 1990, and the data were transmitted back to Earth in May of that year. Voyager 1 and Voyager 2 continue their journeys outward, slowly losing power and capabilities as they drift farther from the Sun. The spacecraft are gradually shutting down their instruments to conserve their remaining energy, and even as their power levels drop, they still manage to send faint signals back to Earth. Even when their instruments eventually shut down, they may continue to send back data for a few years, depending on how much power remains. As they journey beyond the edge of our solar system, these spacecraft serve as a testament to human curiosity, pushing the boundaries of what we can achieve and where we can reach. Long after they stop transmitting, they will continue to drift silently through space, carrying with them the golden records, time capsules filled with sounds, music, and images from Earth, intended as messages to any potential extraterrestrial civilizations that might encounter them. These records include greetings in 55 languages, music from different cultures, and even the sounds of a heartbeat, encapsulating the essence of humanity and our desire to connect with the cosmos. The Voyagers, now eternal travelers of the stars, remind us of the power of exploration and the enduring quest to seek what lies beyond. Their legacy will live on as they continue their silent journey into the unknown, far beyond the reach of Earth, where they will be among the last traces of humanity in the universe, traveling through the void for millions, if not billions of years. As we conclude our journey with Voyager 1, we are reminded of the power of human curiosity and our relentless desire to explore the unknown. This small spacecraft, drifting silently through the cosmos, symbolizes our quest for knowledge and the enduring spirit of discovery. Despite the vast distances, the faint signals it sends back to us continue to deepen our understanding of the universe and our place within it. Thank you for joining us today on Mystery and Quest, the world of science. If you enjoyed this exploration into the farthest reaches of human achievement, don't forget to like, subscribe, and hit the bell icon to stay updated on our latest adventures into the world of science. Until next time, keep questioning, keep exploring, and never stop seeking the mysteries that lie beyond.